Use your knowledge of compound interest to complete the parts below. How much money will you have after 5 years if $1,050 is invested at 7% annual interest compounded quarterly? So I'm going to use our equation here for interest. It could be A or I, it doesn't really matter what the variables are for this. But then we have the principal times 1 plus the rate over how often it's compounded yearly, and then that number times the amount of years. So I'm going to use this one here to help me answer these. So for A, we're looking for how much money we'll have. If we start with $1,050, the rate is 7%. So I'm changing this into a decimal by dividing it by 100. And then I divide that by compounded quarterly. That would be 4 times a year. And then we are putting that money in for 5 years. So now I'm going to go ahead and plug all that in and kind of calculate that to figure out what I have for my total amount of money. So in this one, we end up getting 1,485.52 or 52 cents. So it's about this. It's not exactly, I rounded a little bit. Make sure you get some practice using a calculator to actually evaluate this, because it gets a little bit tricky with the fractions and exponents and everything. So make sure you know order of operations and all of that. It gets a little bit tricky sometimes. So for B, how long will it take the account to have $11,000 if $5,000 is invested at 8.2 annual interest compounded monthly? So this one I'm going to write the equation. I know that I want the amount of money to be 11,000. So I actually know the final amount here. I'm actually looking for the time, so I'll have T in my answer here. So now I got 5,000 as the principal, or the starting amount, times 1 plus the rate, which is 0.082, because I just divided it by 100, compounded monthly, which is divided by 12, and then I don't know what the time is yet. So now I'm just going to be doing this math kind of backwards here. So as we go, I'm going to divide by 5,000. So I don't know what that is off the top of my head just yet. I'm going to put the stuff in parentheses together using a calculator. It gives me like 1.00683 if we want to call it that. Also, I'm just going to divide 11 over 5 is 2.2. And then that's to the power of 12t. And from there, so now to get this exponent to be in just the base, like not have it as an exponent, this is where we have to take the log of both sides. So I don't know if we've done this in a while here, but basically what we're going to do is we need to take the log with the base of 1.00683, because what that will do is get rid of that and leave us with just 12t. So it's really just like the log with this base kind of cancels this out and brings this down. So it's really pulling the entire equation down. But anything we do to one side, we have to do to the other. So I'm going to take log base 1.00683 of both sides. So now I have the log of 1.00683 of 2.2 equals 12t. Now, to evaluate this part here, there's a couple things we can do. Some calculators allow you to plug in a base. If it doesn't, we have this change of base formula that what we can do is we can take the log base 10 of 2.2, which we can definitely do in a calculator, and divide that by log base 10 of 1.00683. So this we can for sure do in even a scientific calculator. Divide those two numbers, we end up getting something like, what is the number that we get? 115.778. 115.778 equals 12t. And then we divide both sides by 12, and we get our final answer of about 9. Sorry, the time is about 9.648 years. For C, write an equation for the amount of money you will have after T years if P to, okay, so we're just dealing with the variables in this one. I'm going to go ahead and do this a little bit to the side over here because I want to be able to see all this. So how much money you will have after T years if P dollars are invested. So that's my principal. What's the rate of our percent? So our rate, so this is the percent. So really I'm going to do like R divided by 100 because I want this to be a decimal. I could technically put the 100 in the denominator too, but I just like it better this way. Oops, and divide by, where's my math here? Oh, sorry. Divide by n times per year, and then to the power of nt. So we'll call it a again. We're really just doing this equation here. The only difference is that we have r divided by 100 because remember the rate has to be as a decimal.